Good evening, students.
Good evening, sir.
Good evening, sir.
Right, students. So what we were doing last week around acceleration, not last week, Monday, right? Last Monday. Acceleration we started, right? And what was acceleration? Anyone remember? What is acceleration? Who will tell me? Yes, Vishnu.
Change in velocity per unit time is called acceleration, sir.
Change in velocity per unit time is called acceleration. Okay, fine. So change in velocity happens when speed increases, decreases, or without change in speed also, there can be acceleration. Yes, Adarsh. Adarsh. What happened to Adarsh? Huh? Adarsh is busy in eating something, it seems. Same time he's sitting in front of the monitor and he's eating something. So now something is there in his mouth. That's why he's not speaking anything. Is it correct, Adarsh? See, he's still not able to say. Yes, I am.
Hello, sir. Hello, sir.
Yes, Adarsh, tell me.
Sir, no, sir, I'm not eating anything.
Not eating anything. Maybe sweet is there in front of you. Are eating sweet, huh?
No, sir, no.
No. Okay, tell me then. Acceleration. Yeah, tell me.
Yes, sir. Can you repeat the question?
That's what I was doing. Acceleration is because of change in speed only, or it can be without change in speed also?
Sir, it can be without change in speed also.
It can be without change in?
Speed, sir. But that should be change in velocity.
How? If there is no change in speed, then how acceleration is possible?
Sir. Sir, if there's change in velocity, then there will be acceleration.
Change in velocity, then there will be acceleration. Okay, suppose magnitude of velocity is not changing. Okay, if magnitude of velocity is not changing, can we still have acceleration?
Yes, sir. Acceleration will be constant.
Acceleration will be constant. Right? Velocity's magnitude is not changing. What will be acceleration then?
Uniform, sir.
You're not understanding. Okay,
sir.
Okay, leave it right now. Let me go to Cyan. Cyan, if speed is not changing, okay, if speed is not changing, can we still have acceleration?
Yes, sir. If the direction is changing, then
Absolutely right. If speed is not changing, then we can still have acceleration if direction is changing. Understood, Adarsh?
Yes, sir.
Vishnu, you also, because you also said 0.
Okay, sir. Understood.
Right.
Sir.
Okay, so acceleration is not only because of magnitude of velocity, it is also because of direction. Okay, change in direction also because of change in direction also we can have acceleration. Okay, let me give you a question. No, directly we solve the question. What is there in it, right? So, okay, let's frame one question over here. The question says, suppose there is a car, okay, which is moving with 5 meters per second. Okay, let's have these directions also. This is east here, this is west, this is north, and this is south. Okay, so now a car is moving towards east with 5 meters per second. Suddenly it takes a turn towards south without changing in speed. Okay, it takes the turn towards south without changing in speed. Right? My question from you is, what is the change in velocity? Because what we said is acceleration's direction is the direction of change in velocity. Acceleration's direction is same as direction of change in velocity. Okay, so here what I'm asking you in this question I am asking you, what is the change in velocity? Find change in velocity here. Change in velocity of car. This car. Okay, there is a car. 5 meters per second is moving and then suddenly it turns towards south with 5 meters per second. What is the change in velocity? Come on, note the question. Yes, students. In 1 minute, if you're not able to understand, then please tell me. I'll start. Hmm? Students,
So what is the time here, sir?
time why you require for change in velocity, why time required? For acceleration, you require time, no?
Okay,
I
sir.
didn't ask acceleration. I asked only change in velocity. Come on, come on.
Sir, only change in velocity, that means root of v1 square plus v2 square, sir.
Absolutely, absolutely correct.
So then 5 root 2, sir.
Yes. Direction you have to tell me. What is the direction? Okay. GB, what's the answer?
Sir, I got as root over 50, sir.
Hey, root over 50 you got. And 50 is what? 5 root 2 only, no? What is 50? 25 into
Yes,
2?
sir, yes, sir.
5 root 2. Direction you tell me. What is the
Yes,
direction?
sir.
This is V1.
So
And this is V2. Yeah, tell me fast. Direction? Something 45 you were saying. Okay, you are having some audio problem. Okay, no issues. So see now, acceleration I want. Others, Vishnu? No, acceleration I don't want.
Direction towards south, sir.
Direction towards south. No, yeah. Okay, what we want? Change in velocity. V2 minus V1. Okay, best way is always put this along with I and J. It makes our problem easy. So this is what basically. Now I told you like this. Okay, this was east, this was west, this was north, and this was south. Now we know that this is called y-axis for us. This is called y-axis. So this I can say this is 5 minus j, and this is 5y. Correct or not? So now V2 is what? 5 minus j minus V1. V1 is what? 5y cap. So actually, if you take negative outside, it is actually what? 5i plus 5j. Correct only. This is also minus and here is also minus. I took minus common. So it becomes 5i plus 5j. Minus 5i plus 5j. Correct only. Right. Minus 5i and minus 5j. What does that mean? Just look at in the diagram. What is the meaning of that? Minus 5i means this direction. This is called negative x-axis. Minus 5j means this direction. And we are adding both. Minus 5i and minus 5j we are adding. Parallelogram law. What is the result? Result is here. Resultant of parallelogram law means diagonal. Diagonal of parallelogram. What is the parallelogram here? Rectangle, or rather square. This is also 5. This is also 5. This is the direction. What is the value? What is the magnitude? You have to add 5 and 5 only, no? So magnitude wise, what it will be? Magnitude wise, root over 5 square plus 5 square. Root over 5 square plus 5 square. What will come? Root 50 you say, or 5 root 2 you say? 5 root 2. Direction is this. Now what is this direction? Because this and this are equal, this will be 45. That is change in velocity. Magnitude of velocity is same, 5, 5. But change in velocity happened. Its magnitude is 5 root 2. Direction is, what is it? 45 degree north of south. Or 45 degree south of north. Both are same thing. Is it clear?
Yes, sir.
Sayan and GV has done. Others, Vishnu, Arunisa, is it clear to you?
Yes,
Yes,
sir.
sir.
Are you
Yes,
sure?
sir.
Are you sure? Everybody, if anywhere any problem is there, please tell me. I'll explain you in detail. There's no issues with me. Okay? Vishnu, Adarsh, Arunisa, any doubt, any problem?
No, sir.
Sure?
Yes, sir.
Okay. Now, if suppose I would have asked you change in velocity, already the change in velocity we have done. If I would have asked you acceleration, what I would have done? I would have given you time. Okay. So velocity is towards east, it becomes towards north or towards south in 2 seconds. Then acceleration we would have got. What would have been change in velocity? Okay. So see, find acceleration if change in velocity takes place in 2 seconds. Okay, what you'll do? Acceleration is change in velocity. Change in velocity is a 5 root 2, 5 root 2 by 2. So acceleration value we would have got 5 root 2 by 2. That is 5 by root 2. 5 by root 2 meter per second square. That would have been acceleration. Direction is same. No change in direction because acceleration's direction is same as change in velocity's direction. Understood that? Is it clear?
Yes, sir.
Yes, sir.
Okay. Okay. Note these points. Then we'll move ahead. Basic points about acceleration. Very basic. Done?
Yes, sir.
Everybody, shall we move ahead? Say something. Students?
Completed, sir.
Yes, sir. Completed.
Yes, sir.
Right. Now see, I'm going to make it little complicated for you now. I'm telling you that this is little complicated. What complication I'm going to put in this? See. Now, I'm going to make one circle. Okay. The circle. And I'm telling you, here, velocity is v. At this point, velocity is v. Okay. Then, at this point, let this angle be theta. Now, velocity is this. And same, v velocity. Right? Here v velocity, here v velocity. Let this point be O, this point be A, and this point be B. Okay. Now, from here to here, it went in time t. Okay. Particle moves from A to B in time t. Now, two things I can ask you. Find change in velocity and then find acceleration. Okay. So find first VB minus VA. Second, acceleration. A little complicated it is. So first you note this question, then so together we'll solve it. Okay. Just note the question, we'll solve it together. Noted?
Yes, sir.
Yes, sir.
Okay. Let's see. We'll solve this. So we have to find VA, VB minus VA. Okay. As far as VA is concerned, I can do like this. I can assume that this is our x-axis and this is our y-axis. Okay. Unit vector over here is I, here is J. We all know that. Okay. So accordingly, I'll be giving the directions to VA and VB. So VA I know already. I don't have to do anything for that. It's VA. Problem is with this VB. This for this only little bit of efforts we have to apply. To see then what we can do. So what I'm doing is I'm just extending it a little. Okay. The construction I'm doing. More construction I have to do. Just see. This all I'm just removing it. Okay. Right. Now what construction? This I'm just bringing it down. Okay. Just see. I'm extending it. Why? Because I have to take the components of this. Because this is not along x-axis nor along y-axis. So I require angle so that I can take components. Okay. I require what? Angle so that I can take components. Okay. What are the methods to take components? There are many methods. I think easier method is also there. Just see that. I'm just telling you the methods. Okay. I took it down, but suddenly I thought I can do one more thing. If suppose I make it like this, vertical over here. I constructed on vertical. Okay. This is also vertical. This is also vertical. So this is what? Transversal. If this is theta, this is also theta. I hope you agree with me. Do you agree with me? This is theta,
Yes,
this is theta. Okay. Now what this is radius of the circle. And this is what? Tangent to the circle. What is angle between radius and tangent?
90 degrees, sir.
Yes, 90 degrees. So this is radius and this is tangent. So total angle is 90. Total angle is 90. This angle is 90. Okay. This is theta. So what this is? 90 minus theta. Yes or no?
Yes.
Yes, sir.
Right. So done. That's it. Finished. Then complication is over. Became very simple. This is 90 minus theta. This is what? Y-axis. Y-axis, no? Y-axis. With y-axis, it's making 90 minus theta. So with x-axis, what it will make? Theta. Theta only. Yes or no?
Yes,
With
sir.
x-axis, theta. Now I can do the work. What work? Now this is V. It's making with x-axis theta. Now what I'll do? I will resolve the vector. Components I will find. Okay. We learned it and how to find the components of a vector. This is theta. So adjacent to theta is cos component. Adjacent to theta is what? Cos component. This is V cos theta. This is V cos theta. And other component is V sin theta. Okay. Adjacent component is V cos theta. Other component is V sin theta. That's it. Done. VB also we got. What is VB? See? V cos theta I cap plus V sin theta j cap. Done. Now what we have to do? VB minus VA. Can we do that? Why not? We can do. First you note this. Any doubt in this first? Because this is the main thing. If there is any doubt in this thing, ask. Yes, students.
Sir, cos theta and sin theta, how, sir?
Okay, you are not there in resolution of vectors. That's why. I'll tell you. Others, sin?
Sir.
Yes, sir.
V cos theta, V sin theta, clear to you people?
Yes, sir.
Sin you?
Yes, sir.
GV, no problem to you, right?
Yes, sir.
Okay, Arunisha, any problem?
No, sir.
Okay, great. Great. So let me just recollect it how we used to do this resolution of vector. It will take me a minute, okay? Just let me do that, then you copy it, okay? So this is a vector. Any vector is given. That can be velocity, that can be force, that can any vector, okay? If suppose any vector A is here, and this vector A is making an angle theta with x-axis, right? Making an angle theta with x-axis. What we are going to do? I am dropping a perpendicular from here on. Now what this is? This is a right angle triangle. Okay. What I want this value. This value. This I am saying is x component of A. What is that? X component of A. I want to find it. What I'll do? I'll write cos theta equal to adjacent by hypotenuse. What I have written? Adjacent by hypotenuse. So what is AX value? AX value is A cos. Vishnu, are you able to understand?
Yes, sir.
You got AX value. Now you say that
Yes,
no,
sir, understood, sir.
I want other component. That means I want Y component. So okay, this is Y component. Then so sin theta. Sin theta equal to AY by A. So what is Y component? A sin theta. Then now same vector A I can write as its X component into I cap plus its Y component into J cap. This is called resolution of vector along x-axis and y-axis. If you take their sum, A only will come. What is that? A cos theta and A sin theta. Root over A square cos square theta plus A square sin square theta. What will come? A. Okay. So this is called resolution of vector. Is it clear?
Yes, sir.
Same thing we have done. Exactly same thing here we have done. This vector was V. This angle we got theta. So this component we have written. Remember, adjacent to theta is cos component. Adjacent to theta, adjacent to angle is cos component. Then other component is sine. That's how we remember. Adjacent to the angle is cos. Okay. So here is V cos theta I cap, V sin theta j cap. Now you note this first. Come on, everybody. Done?
Yes, sir.
Okay.
Sir, one
Now
minute,
what?
sir.
Okay, okay, do it.
Completed, sir.
Right. Now we have to find what VB minus VA. VB we know, VA we know. Okay. Both are there. We have to find what magnitude only we are interested in. Okay. So VB minus VA is magnitude we want. Okay, fine. Magnitude means like this. So what will come? What is the formula? But before that, let's write VB minus VA. Okay. Then we will go for the magnitude. Let's write. Okay. What is VB? V cos theta I cap plus V sin theta j cap. V cos theta I cap plus V sin theta j cap. Then minus Vi cap. Okay, so minus Vi. Now I cap you write together. V cos theta minus V I cap plus V sin theta j cap. We can simplify a little more. We can take V also outside. Then cos theta minus 1 I cap plus V sin theta j cap. Perfect. Done. This much also done. Now magnitude we'll find. Okay, let's find magnitude. Okay, no issues. Now we have simplified it. Only two components I have. One is along x-axis and one is along y-axis. So what will be the magnitude? Square of this inside square root. That's all. That's the magnitude because I and j are there. Okay. So VB minus VA's magnitude is square root of this and square of this. V cos theta minus 1 square plus V sin theta whole square. That's all. Okay, so here is V square, then cos square theta plus 1 minus cos. And here V square sin square theta. Right? Okay. Now what we can do? So V square cos square theta plus V square sin square theta is there. So what we can do here also? V square cos square theta, bring it here. V square sin square theta, then plus V square minus 2V square cos theta. If I'm doing any mistake, immediately tell me, sir, this I missed, or this plus minus sign mistake I have done, or multiplication I have done wrong. Okay. V square cos square theta, okay, plus V square minus 2V square cos theta here, V square sin square theta here. Is everything okay?
Yes, sir.
Okay, great. Fine. Now V square cos square theta plus V square sin square theta. What will write?
V square.
V square. Why? Because we can take V square common from here. Okay. I'm just erasing this thing. This question I am removing now. In fact, I can remove the diagram also, but let diagram be here only. Okay. So V square I took common from here. V square. Then we have cos square theta plus sin square theta. Then plus V square. Then minus 2V square cos square theta. Minus 2V square cos theta. Okay. Cos square theta plus sin square theta. Everybody knows this one. Okay. So V square plus V square. So that is 2V square minus 2V square cos theta. Still not finishing, huh? 2V square also common. Then what we have? 1 minus cos theta. Oh. Do I want this? No. I want more simplification. I want a formula. A particular formula I want so that I can use it whenever the question is asked. Okay, so that means I want further simplification of this. 1 minus cos theta. Right? 1 minus cos theta, what to do? We have to go for another formula then. Okay, note first. Note it. Any doubt is there in this? Whatever I have solved so far on the board, ask. Come on, students. Any doubt?
No, sir.
So,
Vishnu and GV told me no doubt. Others, Sayan, Arunisa, please
No
keep
doubt, sir.
responding. Okay. Others? Again, others started.
No,
Others? Arunisa?
sir, I'm having some internet problem, sir.
Yeah, I understand. But I can make a little bit of joke. No, what is the problem? Any issues there? Do you mind? Others?
Sir, no, sir.
No problem. Then that's fine. Arunisa, what about you?
Sir, 1 minute, I'll log in from another device, sir.
Sure. Arunisa, any doubt?
no, sir.
Okay, great. So first you note it first so that we can get a small formula for this. Okay. Completed?
Yes, sir.
Okay. Right. So this space is there for us. Let's solve them. Okay. Now we want to simplify it further. 1 minus cos theta is there. Something I need to do with that. Okay. I know one formula. I will use that. What formula I have? Okay. I know that cos 2 theta was cos square theta minus sine square. Cos 2 theta was cos square theta minus sine square theta. This formula you also have to remember. If you forgot, recollect it. Okay. In our earlier classes, I told you how it came. Okay. The cos 2 theta equal to cos square theta minus sine square theta. Again, cos 2 theta is also what? 1 minus 2 sine square theta. 1 minus 2 sine square theta. How? This cos square theta we can write 1 minus sine square theta. 1 minus sine square theta minus sine square theta. That means 1 minus 2 sine square theta. Same way, cos 2 theta is one more formula is there. 2 cos square theta minus 1. Fine. I'm writing cos 2 theta only, but here is cos theta. No issues. Same formulas we can write for cos theta. How? Just see. Cos theta equal to cos square theta by 2 minus sine square theta by 2. What I did? Angle became half. Here also half, here also half, here also half. That's all. Same way, cos theta can be written as 1 minus 2 sine square theta by 2. Same way, cos theta can be written 2 cos square theta by 2 minus 2. Right? No problem. So now I have 1 minus cos theta. So 1 minus cos theta, I can write as what? Check here, this one. 1 minus cos theta, I can write what?
2 sine square theta by 2.
Absolutely correct. 2 sine square theta by 2. So I'll be putting it here. It's 2v square into 2 sine square theta by 2. Okay. 2 sine square theta by 2. Okay. Now what? It will come out of this. This is 2 into 2, 4. Okay. 4v square sine square theta by 2 is there. Okay. Just remove this now. Enough. Okay. Let's get the answer. Right. So here is 4v square sine square theta by 2 square root. So what will come? 4 square root is 2. V square square root is v. Sine square theta by 2 is sine theta by 2. So change in velocity's magnitude is 2v sine theta by 2. What is it? 2v sine theta by 2. Okay. This is vv minus vs magnitude. This is our answer and this is the formula. If you remember this, We can get the answer in seconds. 2v sine theta. Suppose 90 degree is the angle. Okay, subtended at the center. So 2v sine 90 by 2. Sine 90 by 2. Sine 45. Sine 45. 1 by root 2. Answer is root 2v. Understood that? And if suppose v is given 5. V is given 5. Previous question. 2 into 5, 10. 10 into sine 90 by 2. Sine 45. 10 by root 2. 5 root 2. Previous question's answer. 5 root 2. Direct formula. Getting it?
Yes, sir.
Yes.
2v
Yes,
sine
sir.
theta by 2. Okay. This is change in velocity. Acceleration. Acceleration is what? Change in velocity by time only. No. So change in velocity means vv minus va by t. That means 2v sine theta by 2 into t. That's acceleration. Done. Both questions over. Is it clear, students?
Yes,
Yes, sir.
sir.
Okay. Note that one. This formula is important for us. Note it. Completed?
Yes, sir.
Okay. Yes, students, everybody?
1 minute, sir.
Okay. So in this one, how many formulas I have told you to remember? This 2b sine theta by 2 is 1. And these cos 2 theta formulas, all we have to remember. Okay. All are equally important. Right? Note it.
Completed, sir.
Right. Okay. Let's go back to the basics again. What basics? Acceleration, we said that change in velocity per unit time. But that was average acceleration. Instantaneous acceleration, we said it's dv by dt. Instantaneous, we said dv by dt. Perfect. Absolutely fine. Okay. But we also have studied v as ds by dt or dx by dt. Okay. Rate of change of position. What is v? V is rate of change of position. V is dx by dt. X is what? Position here. Okay. Or dx is change in position. X is position. So v is dx by dt. And acceleration is dv by dt. So in place of v, if I am going to write, this is a instantaneous. If I write d by dt, and here v's place I write dx by dt. So what is the meaning of this? This is called double differentiation of position. Okay. What is that? Double differentiation. We write it like this. Okay. D square x by dt square. What is the meaning of that? If position is given as a function of time, so to go to the acceleration, we have to differentiate it twice. If velocity is given, we'll differentiate it once to get the acceleration. If position is given, we have to differentiate it double to get the acceleration. So A is equal to d square x by dt square. Okay, two formulas, one for position, one for velocity. Okay, and there is one more formula. A instantaneous. We have written dv by dt. Perfect. There's no problem with that. But what I'm going to do is I'm going to multiply with dx and divide with dx. Multiply and divide both. Does it make any difference over here? No, because dx by dx is 1. It will still remain dv by dt. Okay, there is no problem. But now I'm going to rearrange it. How? I'm going to write dv by dx and dx by dt. dx I brought here, dt I took there. dv by dx into dx by dt. But dx by dt is what? I have written it as v, no? So we have one more formula for acceleration, and that is, this I'm writing as v. So it becomes v dv by dx. Three formulas. One, we already know. Second formula. And third formula. Where to use, how to use, we'll see that. Okay, but first, note it. Okay. Done?
Yes, sir.
Right?
Yes.
Okay.
Yes, sir.
So let's do some problems on this one also. What problem? Easy problem to start with. Very easy. Say velocity, instantaneous velocity. Okay. Instantaneous velocity of a particle is given as, suppose 3t square minus 2t plus 5 meter per second. Whenever velocity is given as a function of time, it is instantaneous velocity. Remember, it's not average. Okay. What is it? Instantaneous velocity. So velocity is given like this. Instead, I'm asking acceleration from you. Okay. Find acceleration at t equal to 2 seconds and 4 seconds. Okay. Asking acceleration at 2 seconds and 4 seconds. Which acceleration is asking? Instantaneous. Okay. Note the question. The first question, so we'll solve it together. Okay. Note it. Noted.
Yes, sir.
Okay, let's do then. Solution says acceleration, we have to find instantaneous acceleration, and we know that what we have to do, we have to do differentiation of velocity. What we have to do? We have to do differentiation of velocity. Okay, with respect to time, yes, it's given as a function of time, so differentiation with respect to time. What do you do? So 3 is outside, then d by dt of t square. Then what? Minus 2 is outside, d by dt of t plus d by dt of 5. Okay. So here differentiation of t square. Differentiation of t square is
2t.
2t. Right, 2t. Differentiation of t
1.
1. 1. Perfect. Differentiation of 5.
0.
0.
So I'm not writing. Okay. So we got it what? 6t minus 2. Okay. This is the function. Instantaneous acceleration function is 6t minus 2. He is asking at t equal to 2 seconds. Okay. So acceleration at t equal to 2 seconds. What you'll do? We put 2 over here. What else? 6 into 2 minus 2. 6 into 2 minus 2. Answer 10. Okay. 6 into 2 minus 2. Then at t equal to 4. A at t equal to 4. So 6 into 4 minus 2. That is 22. Variable acceleration. Acceleration is changing. Okay. At 2 seconds it is 10. At 4 seconds it becomes 22. It's variable acceleration problem. Okay. So we found it. What is the acceleration at 2 seconds as well as 4 seconds? Someone do that. Done?
Yes, sir.
Yes, sir.
Okay, let's go for the next. Now I'm going to use for position. From position, we'll be finding acceleration. Okay. So see now, position I'm giving you now. Question is x is given. X can be given, d can be given, s can be given. They can use any notation. Okay. So x is equal to, let's say, t cube plus 3t square minus 60 plus 2 meter. Okay. Find acceleration at t equal to 1 second and 3 seconds. Okay. Note that this is also first time. So we'll do it together. Okay. Then
Yes, sir.
okay. Right. So acceleration. Now acceleration, we know what? We know acceleration is dv by dt. And we also know v is dx by dt. So that means d by dt dx by. This much we have. That is acceleration. So first thing, from x we'll get v. What is v? Dx by dt. So let's differentiate this and get v value. Okay. So d by dt of t cube plus 3 d by dt of t square minus 6 d by dt of t plus d by dt of 2. Right? Now what? D by dt of t cube. What is it? Come on, tell me.
3t
3t
square.
3t square. Good. Differentiation of t square?
2t.
Yes, sir.
2t. Differentiation of t?
Minus
Minus 6.
8. Differentiation of t is minus 6.
Sorry, 1, sir. Answer minus
Yeah,
6.
yeah, that is correct. No problem. Differentiation of 2?
0.
0. Okay. So 3t square plus 6t minus 6. Now this is velocity. Okay. Is he asking velocity from us? No. He's not asking velocity. He's asking acceleration. We got velocity. Now what to do? We have to differentiate it one more time. Because dv by dt, this we have to find. Velocity we got. We have to find acceleration. Okay. So like previous question, we have to do it. Now we have reached to the level of previous question. Because this is the velocity we have got. Now acceleration we have to get. Acceleration dv by dt. All right. One more time. This is v. So 3 d by dt of t square. Then plus 6 into d by dt of t. Then minus d by dt of 6. One more time differentiation. Again, d by dt of t square. Arunisa, are you getting?
Yes, sir.
Are you getting that how differentiation we are able to do? How t square is becoming 2t, that all you, have you seen that in video? No.
In the app, I have seen it, sir.
So you know, right? You know it right now. Right?
Now only learning, sir.
Okay. Okay. So d by dt of t square. D by dt of t square is 2t. Okay. So 2t here. Plus 6. Then d by dt of t is 1. So not writing now. D by dt of 6 is 0. So acceleration I am getting is 60 plus 6. Is it clear to everybody? Any doubt?
No, sir.
No,
Sir.
sir.
Okay. So now question is asking us acceleration at t equal to 1 second. What it will be? You tell me. Put the value of t and tell me what is acceleration at 1 second.
Sir, at 1 second it is 12, sir.
Yes. At 3 seconds.
At 3 seconds it is 24.
24.
Perfect. Note it fast now. Note it. Done?
Yes, sir.
Yes, sir.
Okay. Okay. Now, see, question is given in different way to you. Velocity is given, but it is not given as a function of time. It is given as a function of position. V is given alpha root x or a root x, where x is position and alpha is constant. Okay. X represents position and alpha is constant. Okay. What I want in this? In this one, let's calculate acceleration first. Okay. As a function of position only. Okay. Find acceleration as a function of x, as a function of position. Okay, note that. Okay, done?
Yes, sir.
Okay. Now when v is given as a function of x, how to get acceleration? Because acceleration is dv by dt, you know. But at the same time, I told you one more thing. Acceleration is also v dv by dx. This is also acceleration. So in this one, what I have to do? I have to just look at this thing. This is what? If you see that, it is basically differentiation of v with respect to x. So do differentiation with respect to x and multiply it with v, you will get acceleration. So this we have to differentiate. We have to find dv by dx. Okay, no issues. So v equal to alpha root x is there. Now I have to do dv by dx. So dv by dx basically is alpha d by dx of root x. Root x means x to the power 1 by 2. Root x is what? X to the power 1 by 2. And what is this differentiation? Its differentiation is alpha is as it is. Differentiation is 1 by 2 x to the power 1 by 2 minus 1. That's it. X to the power n dx. Differentiation of d by dx. Differentiation of x to the power n is what? N x to the power n minus 1. Or d by dx of x to the power n is what? D by dx of x to the power n. What is the formula? N x to the power n minus 1. So here what is n? Half. So half comes out x 1 by 2 minus 1. This is the formula. What we got? Alpha by 2 x to the power minus 1 by 2. X to the power minus 1 by 2. What is the meaning of that? Alpha by 2 root x. Alpha by 2 root x. That is dv by dx value. What you'll do? I'm going to put it here. Okay. We are going to put here, but what is v? V is alpha root x. So write alpha root x into dv by dx is alpha by 2 root x. Root x cancelled. Acceleration value is alpha square by 2. Able to understand?
Yes, sir.
Yes, sir.
Everybody?
Yes, sir.
Yes, sir.
Okay. Note it. Note this. Completed?
Yes, sir.
Yes, sir.
Okay. Now I am erasing this one and I am framing new question from the same relation. Okay. New question from the same relation now is find position of the particle as a function of time from this only. Okay. What is it? Find position of the particle as a function of time. That means we have to bring time in this. Find position of the particle as a function of time. We have to bring time, and we don't want v in that. There's a relation between x and t we want. Okay, note this. I'll tell you how to do that. Then
Yes, sir.
okay. So v equal to alpha root x is given, and we have to bring time. What we can do, this v, we are going to write dx by dt. We know that v is dx by dt. Write it. Dx by dt equal to alpha root x. So v is gone. Okay, we have removed v. Now what we can do? This root x I am going to bring here. This is dx by root x. Then this becomes alpha dt. Okay, x on one side, t on the other side. Now what? Dx by root x. This is not dx by dt. Dx by root x, or x to the power minus 1 by 2 dx equal to alpha dt. What this is? This is integration function. This has become integration. Now we have to integrate this. Yes. After integration only we'll be getting the x as a function of time. Okay. Okay. But in this one more thing I will be adding. Okay. Without that, it will not be possible in the question. What is that? Find position of particle as a function of time initially. Okay. What will write? At t equal to 0, x is also 0. Because this is required. If we do not have this, then how to put the limits? Without limit, we can't solve it. So what are the limits? We'll say, see, 0 initially here, at t equal to 0, x was 0. Now what we want? At time t, I want what? X. So x as a function of time I want. Okay. So here 0, t, x. Done. Now what? Integration of this. What is integration formula? X to the power n dx is what? X to the power n plus 1 by n plus 1. Okay. What is integration formula? If you forgot, then x to the power n dx is x to the power n plus 1 by n plus 1. Right? Here we'll do that. Yes. So x to the power minus 1 by 2 plus 1. Once again, I will write it proper way. X to the power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. Done? Over? Yes. Then limits are 0 to x equal to alpha. Alpha is constant. Dt is integration t. So t 0 and t. Now put, no, not first you solve this. This is x to the power half, and this is minus 1 by 2 plus 1 means 1 by 2. So 1 by 2, 2 will come at the top. Okay. So 2 x to the power half. Now limits 0 to x, and here you can put the limit directly. What is that? T minus 0. Okay, put the limit here also. First x, so x to the power half, minus 0, 0. Done. Everything is over. What is the final relation? This is 2 root x. 2 root x equal to alpha t. Okay. Root x equal to alpha t by 2. But x equal to what? X means a square both sides. So x will be equal to alpha square t square by 4. So x value is alpha square t square by 4. That is the relation. X is equal to alpha square t square by 4. Did you understand?
Yes, sir.
Yes, sir.
See that how much differentiation and integration are used, okay, in kinematics only. Still we have not started equation of kinematics, v equal to u plus at, s equal to ut plus half at, so nothing. Just basics we are learning, but so much differentiation and integration is there. Okay, first we found acceleration as a function of displacement. Now we are finding velocity as a function of time. Position as a function of time. After this, I'll say you velocity as a function of time. There also we'll use differentiation and integration. Okay, note this. Note this. Is this clear to everybody? Any doubt is there? Please ask me.
Sir, no doubt, sir.
Okay, great. Done?
Yes, sir.
Okay.
Yes, sir.
Now next is what? Find velocity as a function of time. Find velocity of particle as a function of time. This is given as function of position. Now we have to find velocity as a function of time. Okay. Can I clear everything? Students, can I clear everything?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So let's clear. Okay. I accept the answer of this last question. I'll clear everything. Why? Because from there only I'll be finding velocity. Right. X is given. We've got the x value. Position as a function of time is there. Alpha square t square by 4 we calculated. Now v only we have to find. No. So what is v? V is dx by dt. Simple. Alpha square by 4, then d by dt of t square. As simple as that. What is the answer? Alpha square by 4. T square differentiation is 2t. Answer is alpha square t by t. That's all. Is it clear?
Yes, sir.
Yes.
Okay, note it. Complete.
Yes, sir.
Okay. Right. Now if I ask you, find average velocity. Okay. See how what I'm doing. Now I'm asking you, find average velocity of particle in covering first s distance. That means from the start it must have covered some s distance. In covering s distance, what will be the average velocity of this part? That's the question for you. How are we going to do it? Right. Okay, note the question. Done?
Yes, sir.
Yes, sir.
Okay. So average velocity, when I say average velocity, I'll say total displacement by total time. Okay, or average speed also here, because we are not talking about change in direction. So average speed and average velocity will have same value. So total displacement by total time. He has already given us displacement. How much is this? Displacement is S. Okay. So S. Now, if I can find out how much time it has taken to travel S distance, my work is over. After that, what I have to do? Nothing. So in first S distance, how much time it has taken, can we find? Yes, that's why I have written this relation. X is what? Position. Initial position is 0. When it travels S distance, what will be its position? S, because initially it was 0. So I'm writing here S. So S equal to what? Alpha square T square by 4. That means I want this time when it is at position S. Okay. What it will be? 4S equal to alpha square T square. So then 4S, not alpha S, 4S by alpha square. 4S by alpha square equal to T square. So what is T? I want T. T value is 4S by alpha square root what else? This is T. T equal to root over 4S by alpha square. That's all, finished. Now simplify that. This alpha square will go up. Root over alpha square into S by 4S. So what is here? Alpha S, and this 4S is in square. Okay. 4 square root is 2, and then root S. What is the answer? Answer is alpha root S by 2. That's V average. Did you understand, students? Don't feel that all the questions will be asked in one question as we did. One. Any one question at a time. Don't feel all the questions you will be solving in one question. We have solved 5 to 6 questions in this itself. 6 different questions. Okay, I think 6 we have solved. No? How many? Just take
4, sir.
4. Acceleration, position, velocity, time, average velocity. 5 questions. Okay. Is it clear?
Yes, sir.
Yes, sir.
This is 5th question. Okay. Sorry, 4th question. This is 5th question. Note it. Done?
Yes, sir.
Okay. Right, sir. Now, what the question is? Next is different type. Okay. Similar type of questions will not repeat. Different type of question. What is it? Okay. I'm giving a position. 10 plus 60 minus 3t squared is the position of particle. Okay. This is position of particle given to you. What do we have to do? What do we have to find? From here, velocity we can find very easily, right? We have to differentiate and we'll be getting velocity immediately. Okay. Then what shall I ask you? Okay. Let's do it like this. Find velocity only. Okay. Find velocity of particle at t equal to 0. Okay, and also find distance traveled by particle before coming to rest. Before coming to rest. Okay. Position is given like this as a function of time. First, you find what is the velocity at t equal to 0. Is it traveling or not traveling? If it's not traveling, then it's traveling 0 distance because it's already at rest. But if it is traveling, then we have to find how much time it will come to rest. And then at that time, how much it will travel. Big question. 3-4 questions are there in it also. Okay, come on. Now, first question I'm leaving out on you. You are going to tell me what is the velocity of the particle.
Sir, 6 meter per second, sir.
6 meter per second. Positive, negative, how it is?
Positive only, sir.
Positive, sir.
Okay. So velocity first of all is dx by dt. Differentiation of this. Differentiation of 10, 0. Differentiation of 60, 6. Differentiation of this one. What is that? 3t square is 60. 6 minus 60 is velocity as a function of time. Directly now differentiated. Now I'm not writing d by dt, this, that, everything. That's how we can reduce the time. Because every time if I write, you will find like very lengthy we are doing. This is how in one step we can do it. So 6 minus 60. Okay. And then I ask you velocity at t equal to 0. Perfect. 6 because t is 0. So 6 meter per second. It's traveling. It's traveling. Right. 6 meter per second. Why second square? Meter per second. Okay. Now, when it will be at rest? When it will be at rest means when velocity is going to become 0. We can find. We'll put 0 over here. Okay. Particle will come to rest. That means v equal to 0. What is v? 6 minus 60. 6 minus 60 equal to 0. That means t equal to 1 second. Am I correct?
Yes,
Yes
sir.
or no? Right. At t equal to 1 second, it will come to rest. So how many questions we have already found? We found initial velocity. We found how much time it will come to rest. What we have to find actually? Distance traveled by particle before coming to rest. So particle is coming to rest in 1 second. So how much distance it will travel? What to do? In this one, first, put t equal to 0 and see where the particle is. Then at t equal to 1, see where the particle is. And then find the difference between the two. Then only we'll say that how much it has traveled. Understood that? At t equal to 0, first find out where is the particle. Then at t equal to 1 second, find where is the particle. Then find the difference. Okay. So x at t equal to 0. Put t equal to 0 here, put t equal to 0 over here. What will come? 10. Okay. Here also t equal to 0. Here also t equal to 0. What is remaining? 10. Now at t equal to 1, you find. Okay. So now 10, then plus 6 into 1, minus 3 into 1 square. 10 plus 6, 16. 16 minus 3, 13. So x equal to 0, it is at 10 meter, and at x equal to 1 second, it is 13 meter. How much it has traveled? 3 meter. Answer is 3. Did you understand?
Yes, sir.
Sir,
Great. Note it. Done?
Yes, sir.
Okay. Right. One more question we'll do. What is this question now? Acceleration we'll be writing. What shall I give you? Acceleration as acceleration is constant. Shall I give alpha? Will that be okay? Yes. Okay. So acceleration of particles is given as alpha. Okay. Find velocity as a function of displacement x. That means position x, displacement x or position x. Okay. Initially at x equal to 0, velocity is u. Okay. Initially at x equal to 0, velocity of particle is u. Okay. Okay, note the question. You'll be surprised to see the answer. If possibly, if I have made the question correctly, we'll get what I want. Okay. Write the question. Completed?
Yes, sir.
This is constant acceleration. It's not variable acceleration, constant acceleration. But he's asking velocity from this and as a function of position. What to do? Acceleration, I know velocity dv by dt, but he's not asking as a function of time. He's asking as a function of position. So acceleration will be writing as v dv by dx, the other formula, equal to alpha. No problem. We can write like this also. Now what? Now v dv equal to alpha dx. Then, now what? Integration. It's given to us that initial position 0, initial velocity is u. Okay. Then here is position x, then its velocity we can say is v. Then, okay. What is integration of v dv? What is integration of x dx? X square by 2. I told you, no, x to the power n dx. Same formula we'll use again, x to the power n plus 1 by n plus 1. So here in place of x, what is given? V. V dv. In place of x, v is here. V to the power 1. What will come? V square by 2. Here is u, here is v. And here, this is dx, that means x to the power 0 dx. X to the power 0 dx. So what will come? X to the power 0 plus 1, that means x to the power 1 by 1. So here will come alpha as it is, here is x. That's it. Yes, integration over. Now put the limits, first v and then u. So v square minus u square by 2 equal to alpha. Then put limit here, x minus 0. So that means x. What we are getting? V square minus u square equal to 2 alpha x. Do you remember this? V square
Yes,
equal
sir.
to u square plus 2 alpha x. What is that?
V square minus u square equal to a, sir.
Right, because acceleration only is alpha, no? So in place of alpha, I can write a. Third equation of kinematics we derived. V square equal to u square plus 2ax. This is third equation of kinematics. Surprised? No. Not surprised. Nobody surprised. Everybody was knowing that what I'm going to do, right? Good. You can guess it what I'm going to do, right or not? Very good. Okay, noted. Is there any doubt in this one?
No, sir.
No, sir.
Okay, 2 no's are coming. The remaining 3?
No,
No,
sir.
No doubt, sir.
Okay, great. Noted. Completed?
Yes, sir.
Okay. Now let's quickly talk about equation of kinematics. We all know what equation of kinematics are. Okay. But one thing we do not know is when to apply them. So far, we were not applying any equation of kinematics. Were we able to solve the questions? Yes. So there is limitation of equation of kinematics, where to use them, where not to use them. It's very, very important for us to know. Okay. So first thing is where to apply equation of kinematics. Equation of kinematics can only be applied when acceleration is constant. Okay. Write that. Equation of kinematics can only be applied when acceleration is constant. And acceleration is constant. That's very, very important. If acceleration is not constant, then what? Then we use differentiation and integration to get the answer. If acceleration is not constant, we'll use differentiation and integration. But if acceleration constant, can we use integration and differentiation? Yes. Integration and differentiation we can use for all. If we are very thorough in integration differentiation, we feel comfortable in that, okay, we can do that. Okay. But if acceleration is constant, we can still solve it with equation of kinematics. So equation of kinematics do what? It makes problem solving a little easy for us, a little easier than differentiation and integration. So particularly for acceleration constant, we prefer. Okay. Let's derive. We all know what these are. We all know the equations are there. V equal to u plus at. S equal to ut plus half at square, or you can put it like minus also here. Okay, same way, v square equal to u square plus or minus 2as. So these are actually equation of kinematics. Why minus I have written? Because you can have retardation also. Acceleration can be negative also. Okay, so that's why we have written minus. But I didn't tell you, no, when acceleration will be negative and when acceleration will be positive. I didn't discuss with you. Do you know about it? When acceleration is positive, when acceleration is negative? Who's going to tell you? Yes, Vishnu?
Sir,
When is acceleration positive? When acceleration is negative?
when change in velocity is positive, acceleration is positive, sir.
Okay. Right. When change in velocity is positive, that means if we are talking in 1D motion now, forget about change in direction. Okay. There is no change in direction happening here, 1D motion only. So if I say that if velocity is increasing, acceleration is positive. If velocity is decreasing, acceleration is negative. Very simple. Okay. If or velocity, if I make it more simpler, let's say speed. Okay. When we are talking about 1D motion, okay, we are talking about 1D motion, that means no change in direction. Okay. So if speed increases, acceleration is positive. Or vice versa. If acceleration is positive, means speed will increase. Okay. If speed decreases, acceleration is negative. Acceleration negative when it happens? When you apply brake. Okay. Braking. And acceleration is positive when you accelerate. Accelerator is there, no? In car, in bike, everything. Accelerator. When you accelerate, what happens? Speed increases. When you apply brake, what happens? Speed decreases. So braking, and here is acceleration. Acceleration, everybody knows actually. Okay. What is the term we use for this braking? Retardation or deceleration. Okay. Negative acceleration means retardation or deceleration. From these two words, anything can be used. Then we call acceleration is negative, then we call acceleration is positive. Note this also, then we'll derive the equations. Come on. Done? Completed?
Yes, sir.
Okay. Right, students, let's go for equation number 1. Equation number 3 already we have derived. Okay. That we are not deriving again. V square equal to u square plus 2ax. We already did. Okay. Remaining 2 we are going to derive. First equation. V equal to u plus at. What shall we do? Do we require to derive it? Not really. Why? Because acceleration is what? Change in velocity by time. Average acceleration is change in velocity by time. Change in velocity means final velocity minus initial velocity by time. So final velocity means v, initial velocity means u by t. That only, no. Acceleration is what? v2 minus v1 by t2 minus t1. But since we are talking about one-dimensional motion, so we know that velocity equal to speed. So initial velocity we represent with u, final velocity we represent with v, acceleration with a, and time is t. What is v? Final velocity. What is u? Initial velocity. And what is t? Time taken. Time taken in what? In increasing the velocity from u to v. Okay. Time taken in increasing the velocity from u to v. So what is this? This is first equation of kinematics. That is at equal to v minus u. So v equal to u plus a. First equation came from our formula of acceleration only. So you don't have to derive it. We don't have to derive it. But if you are very interested, no, sir, we should derive it only, sir. We can do that. We can do that. Acceleration is dv by dt, right? Acceleration is dv by dt. So a dt equal to dv. Okay. Acceleration is constant. Keep it out. Okay. At t equal to 0, what is the velocity? U. So t equal to 0, velocity is u. And after time t, what is the velocity? V. Done. Okay. So integration of dt is what? T. Integration of dv is what? V. With limits u and v. Now put the limits. A. Here is t minus 0. And here is v minus u. So what we got? At equal to v minus u. Same first equation of kinematics. This is with integration. This is just with a normal formula. Your wish. First equation. V equal to u plus at. Is it clear?
Yes, sir.
Okay, note that. This is first equation. Done?
Yes, sir.
Okay. Now second equation of kinematics will derive. Second equation. Okay. What is second equation? S equal to ut plus half at square. Okay. So how we'll do? We'll do it by taking what we already have. We have this. We already have this. Now, what we want? S. Okay, S we want now. I don't want V in that. I want S in that. So remove this V from here. Bring S. How? This we can write ds by dt. What else? Done. Now simplify. ds equal to u dt plus at dt. Integration. At t equal to 0, 0, 0, 0. Position is 0. At some time t, position becomes S. Finish. ds integration S, 0 to S. U is constant. T dt is integration T, 0 to T. Acceleration also is constant. T dt means t square by 2. Okay, put here first S minus 0. U here then T minus 0 plus A. This 2 you can take outside. T square minus 0 square. So this is S, this is ut, this is a by 2 into t square. Second equation of kinematics. Did you understand?
Yes, sir.
See,
Yes, sir.
Yes, sir.
right, note it. So all three equations of kinematics we have done, we have derived. Okay, students, done?
Yes, sir.
Yes, sir.
Okay, so let's finish today's class here. Okay, Monday morning we'll be doing more. Okay, right, students? Now tell me about test. Ready for the test tomorrow? Not getting GB saying something. I'm not getting GB. Say again.
I told yes, sir.
Okay. Yes, Adarsh, Vishnu, Sayan.
Yes, sir.
Okay, Vishnu is ready. Adarsh.
Okay, sir.
Okay, Adarsh is also ready. Sayan.
The preparation is going also. I'm also almost ready.
Okay, done. Okay, Arunisa, for you there is no problem at the moment. Okay.
Yes, sir.
Okay. So okay, students, we will have the exam tomorrow. It will be online exam. Okay. Timing, I'll let
timing.
you know. I'll let you know. I'll put it in the group. You'll be getting it. Okay. Is that okay? Timing will be sufficient for you. Okay. You have to, I mean, the window will be open for considerable amount of time. It will be open for 10, 11 hours or 12 hours. You decide whichever time is convenient for you, you can write. Okay.
Yes, sir.
All right.
Yes, sir.
Okay, students, then see you in the next class. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.